Yeah, if you want to ask me at the end of the session, that would be great. Okay, and then we can go over any questions that you have, or you can come to office hours too, but this time would work as well. Okay, good question. Okay, so in Module 2, we are going to be talking about systems of linear equations. And systems of linear equations, there's three types of systems that can happen here when we graph two lines on the same grid. All right, we can see right here, let's see, maybe I'll just use this. You can see right here that the point in which those are, oops, what's going on? Okay, sorry. Guess I'm going to try and use this. Okay. No. Now it doesn't want to get rid of that. Okay, now I've got it. Okay, so we can see right here where those two lines are intersecting. Right. My goodness, I'm so sorry. Oh. Okay, so right there, the two lines are intersecting each other. And so that point in which they are intersecting is called the solution. All right, so it is a point that exists on both of those lines, and it's the only point that exists on both of those lines. So we want to keep in mind here, right, that our solution is going to be some x and y coordinate. All right, so that's one thing that can happen. We can have one solution. Another thing that can happen is we can have parallel lines. And if we have parallel lines, then there's going to be no solution because they're not intersecting anywhere. And so, and then on this last one, it might be a little bit hard to tell, but this one is a line on top of another line. So it's basically when we graph the two lines on the same grid, they end up just right on top of each other. Okay, so let's look at a few things. And then it says down here to fill in some of these blanks. Okay, so the graph of the two equations cross at exactly 1 point. Right, is what we figured out here. Only the solution is true for both equations, right? It's the only point that exists on both of those. Okay, the system we call consistent. Okay, and consistent means that there's one or more solutions. Maybe I'll put that down here so you remember. So the word consistent, whoops, in math means that it has one or more solutions. All right, and then the next thing underneath it, the system is independent as the lines are distinct. They are two different lines. Okay, so if we're talking about if a system is dependent, right, this one that we just talked about is independent, but if it's dependent, whoops, I misspelled that. Got a D there. Dependent means that one equation is a multiple of the other. Okay, and as we work through some examples, you'll kind of see what happens here on this. All right, so now let's look at this when we have two parallel lines. All right, so the graphs of the two equations never cross. They are parallel lines, there are no solutions that are true for both equations. So this system would be considered inconsistent because it doesn't have at least one solution. All right, so let's put here, this one is inconsistent. And the system is independent, again, because these are two distinct lines. All right, and then this last one, when we have a line on top of the other line, the graphs of the two equations are the same. And so any solution that is true for one is also true for the other. There are infinite solutions on this one because every single point, all right, so if we think about here, lines are made up of points, so every single point on here would be a solution because it's one line on top of the other. So this system would be considered consistent because remember, consistent means one or more solution. We've got infinite solutions, so that's definitely one or more. Okay? And this system is dependent because when you look at the equations for these lines, you'll find that, one is a multiple of the other. And so we'll do some where you can kind of see where that happens. Okay. All right. So we're going to just we'll go through some of these. We might skip over some just depending on how time goes and stuff. But if I skip over any of them, feel free to go back and, try and do them on your own to make sure you understand what we're doing here. Okay, so we're trying to find on this first problem, is this point a solution to the system of equations? Does anybody have an idea of how we would determine if this point is a solution? What could we do here? Yeah, you could graph it, right? And if we graph it and that is the point they intersect, then that means that that is a solution. Now, we might not always want to do the graphing, so is there any way maybe we could tell algebraically if that is a solution? Yeah, we can just plug them in for x and y. And we need to do it to both of the equations because, remember, like this point, 2 comma negative 2, could be on that line, but not on the other one. And remember, we said in order for it to be a solution, it has to be a point on both of those lines. So let's go ahead and try that. We'll plug this in. So 2, and then in place of x, I'm going to put 2 plus y, which is negative 2. So plus a negative 2 equals 2. And we're trying to see if this is a true statement. So 2 times 2 is 4, minus 2, does that equal 2? Yeah. So we get 2 equals 2, so that means that first one, 2 comma negative 2, is a point on that line. Now let's check the other one. So now let's use that 3. In place of x, I'll put 2, plus 6. In place of y, I'll put negative 2. Right? I'm just using these x and y's up here. And then equals negative 6. So here I got 6. And then 6 times negative 2 is negative 12, so 6 minus 12. Does that equal negative 6? It sure does. So we end up with this true statement here for both of them. So yes, this point is a solution to those two equations. Okay, so on this one, and it might be kind of hard to see on your screen. I don't know if I can make it a little bit bigger here for a second. All right, we're trying to figure out where the solution is on this graph. Can anybody tell by looking at that where that might be? So this is negative 4, right? And then these are counting by ones up there. So it looks like, yeah, just right where it intersects is what we're considering that solution, right? So negative 4, comma 1 would be our answer on that. Okay, so that is the only point that is a solution on there. All right, let me see if I can get this back. All right, so now let's take a look at a problem here. And hopefully this is looking familiar to you. This 2r is something we're just going to kind of go through quickly because it is something that we're expecting you to know come into this class. But I wanted to review over it a little bit because you're going to be lost if you don't remember how to do these two methods here. So we're going to start off and we're going to solve this linear equation using the substitution method, and then we'll solve it again using the elimination method. Okay, so the substitution method, I'm going to just write on here just to make sure everybody remembers what this is. So with substitution method, we want to get one variable by itself. Okay, first. So first, get one variable by itself. So you're looking to see if there is one of the variables that's easy to get by itself. All right, so looking at both of these equations, which variable do you think would be easiest to get by itself? Yeah, getting that y by itself, right? So if we're trying to isolate that y, let's go ahead and do that. So let me write it down here. Let's see. So if I have this 2x minus y equals negative 5, and I'm trying to solve it for y because I need to get one of the variables by itself. So I'm going to subtract the 2x over. And then I'll have negative y equals negative 2x minus 5. And I'm writing it this way just so it's in that y equals mx plus b form that we talked about in Module 1. But y isn't all the way by itself yet. There's a negative there, so we still need to divide every single part by a negative 1. So when we do that, we get y equals 2x, I'm sorry, we got a negative 5 divided by a negative 1, which is going to give me a positive 5 here. Okay. All right, so I have that variable by itself now. And so now I want to take it, I'm going to show you up here. So I want to take it and I'm going to substitute it in place of that other one. So this is y equals 2x plus 5, right? That's the same thing. We just reordered it so that we could get y by itself. So I'm saying y is all of this stuff. And so now I'm going to put that 2x plus 5, I'm going to substitute it in place of y in my other equation, right? So I'm going to put it right there. So let's go ahead and do that next. So I'm going to have 5x plus 3, and then instead of putting y here, I'm going to take out that y, put in parentheses, and inside that I need to put the 2x plus 5. All right, and then I still have equals negative 7, so let's put that on there. All right, and now I need to solve this for x. So let's start by distributing through here. 5x plus 6x plus 15 equals negative 7. That 7 looks really weird there. Okay, and so now I've got to get my like terms together, right? So here I get 11x, and now I need to, I can also at the same time subtract that 15 over. All right, and negative 7 minus 15 is negative 22. And then the last step is to divide by 11, and then I get x equals negative 2. Okay, so that is just my x coordinate. So when I'm writing my answers on this, I need to write them as ordered pairs. Remember, I write my x first and my y second. So I found that x is negative 2, so I'm going to just put that right in here where my x goes. Okay, now any ideas on how we might be able to find y now that we know what x is? How can we use that x equals negative 2 to help us find y? Let's look at that equation that we just made up here. All right, if we're going to this equation, the y equals 2x plus 5. All right, I know that x is negative 2, so I could substitute that here in place of x. And then that's going to tell me what y is. Okay, so let's try that. So I've got y equals 2 times negative 2 plus 5. So y equals negative 4 plus 5. And when I subtract those, I get y equals 1. So that is my other coordinate, right? My y coordinate on here. So up here, I'll have negative 2, comma 1. And that is my answer. All right, questions on that one? What we're doing there. So first get one of the variables by itself, and then you're substituting that in. Once we get that by this itself, right? Y equals all of this. Put that 2x plus 5 in place of y in the other equation. Okay, and then we solve from there. All right, the other method that you need to get familiar with is called the elimination method. Sometimes we call it the addition method as well. So some books use that. And that's because what we're going to try and do in this one is we're going to try and add the equations together and get one of the variables to eliminate. So let me write on here. Oops, keep clicking on the wrong one here. Okay, so we want to make one of the variables eliminate in both equations. Okay, so I'm going to write these down underneath here again so we can see it a little bit easier. We've got 2x minus y equals negative 5. And then our other one is 5x plus 3y equals negative 7. All right, so if I add these together just the way they are, I'm not going to be able to eliminate any of the variables, right? If I add the x's together, I get 7x. If I combine those y's together, I get 2y. And so I'm not getting a variable to eliminate. So we've got to make it eliminate. And the way that we're going to get them to eliminate is we need to multiply. We're going to multiply this top equation. So I'm going to get rid of my y variables. That one looks the easiest for me to get rid of because I can do that by just multiplying this equation by 3, right? Because then I get negative 3y, I add it to 3y, that zeroes it out, which is what I want. Where if I chose the x's to eliminate, I'd have to multiply both equations by something. So either way is fine, but this way is just a little bit quicker, so we'll do that. All right, so I need to distribute this 3 to everybody, and I'm going to write it down under here. So I've got 6x minus 3y, and then equals negative 15. All right, and so now when I add these together, I can see, yeah, these y's eliminated. They zeroed out. Okay? And then I'm left with, let's see, if I add these together, so I'm not looking at that top one, right? I multiplied that 3 through and I got this bottom one here. So I'm just adding those two together down here. So I get 11x equals negative 22. So again, divide by 11, I get x equals negative 2. All right, and I should come up with the same answer that I did before. We just are doing a different method to get to the same answer. Okay, so x is negative 2, and now just like I did over here, I'm going to substitute that negative 2 back into one of the equations. We didn't get the equation in this form, so we need to pick one of the ones that we had before. So I'm just going to choose that top equation, that 2x minus y equals negative 5, and I'm going to substitute that negative 2 in place of x there, right? So this negative 2 is going to go in here. So I'll have 2 times negative 2 minus y equals negative 5. I get negative 4 minus y equals negative 5. Let's add that 4 over. I get negative y equals negative 1. And then my last step is I need to divide by negative 1. So y equals positive 1. And so that's what I get for my other one. Okay, so we can see that, yeah, it doesn't matter. And the other method that we could use is we could graph the two lines and find the point that they intersect. But sometimes graphing them has a lot of drawbacks because maybe your graph isn't going to be exactly perfect, and so it might be hard to tell where those lines are intersecting each other. Or if your numbers are really big, trying to make a graph that's really big is a little tedious. So doing this algebraically with a substitution or elimination oftentimes is going to be a better way to go. Okay. All right, now I want to look at 2 of these, and then I'll save 2 for you to do. So looking at this first one here, I want you to think about whether the substitution or elimination method might be best to use in this, might be quicker. Anybody have an idea of which method you think you might use here and why? Okay, substitution sounds like a good one to do because we already have one of the variables by itself. There's not even any work that we have to do there. So I can take all of this, 3/2 x minus 1, and I'm going to put it in place of y in the other equation. Okay, so let's do that. Over here, so I've got negative 6x plus 4. And then in place of my y, right, I'm going to put all of this stuff in. So parentheses, 3/2 x minus 1. And then that needs to equal negative 4. All right, so I'm just substituting all that in place of y down here. All right, so let's go ahead and solve this now for x and see what happens here. So first I need to distribute that 4 through. So that really means I'm taking 4 over 1 and I'm timesing it by 3/2. All right, and so if I do that, if I multiply across the top, I get 12. Multiply across the bottom, I get 2. 12 divided by 2 is 6. All right, so that's just a little side work here to figure this out. So I've got 6x. Right, and then when I distributed that through, I found it to be positive 6x. Now I need to distribute that 4 through to that negative 1, so that's going to give me negative 4, and then equals negative 4. Well, look what happens here. My 6's end up zeroing each other out, right? Negative 6x plus 6x is gone. And I'm left with this negative 4 equals 4. So that is a true statement. If I had something like -4 equals 0 or something like that, that would be an untrue statement. So since this is a true statement, that means what we have going on here is that these two are exactly the same line. And they don't look like it, maybe with how they're written, but they are the same line, and I'll show you that here in just a second. And so the answer on this is going to be infinite solutions. All right, so your answer isn't like -4, right? We get this true statement, and that's telling us that our answer is infinite solutions. Okay. So many points, right? Every single point on that line will be the answer. Okay, so let's look at this really quick, because sometimes people look at this and go, those definitely don't look like the same line to me. So how are they the same line? Okay, so let's look at this. So I want to just take this, this bottom one, I don't know what's going on here, and let's go ahead and I'm going to just solve it for y, because that top equation, y is by itself. So let's take this -6x plus 4y equals -4 and solve it for y. So if we add the 6x over, all right, we get positive 4y equals 6x minus 4. And then if I divide everything by 4, all right, look what I end up with here. 6/4 reduces to 3/2 x, and -4 divided by 4 is -1. So do you see how that's exactly the same as that top one that we had there? So it is, in fact, the same line, right? So we got infinite solutions. Okay, then let's try this number 5 on here. All right, with this one, again, it looks like, well, let's see. I want to do that one. Yeah, let's do this. So again, it looks like it's easy to get y by itself here in that second equation. So I'm going to start by dividing everything by 2 so I can get y by itself. When I do that, I get y equals 1 minus 4x. Okay, everybody with me there? All I did was try to get y by itself, so I divided everything by 2. So now y is by itself, so I can take all of this and put it in place of y in that in that first equation. So let's do that. So a different color here. So if we have 4x and then plus this 1 minus 4x equals 3. All right, well, again, we can see 4x minus 4x, those zero out, right? Those are gone, and I'm left with 1 equals 3. So is that a true statement? Definitely not. 1 does not equal 3. So when you get a false statement, then your answer is going to be no solution. Okay. All right. Okay, I'm going to skip over those other two. If you want to go back and try those out yourself, you're more than welcome to. Okay, but I want to get to some of the stuff in 2.1 because these are talking about story problems now, solving them using the systems like I was just talking about up above. So we're going to use the substitution or elimination method to help us do this. Okay. All right, so let's try try to decide if I want to do that one. Let's do this problem number 2. All right, so in math, does anybody remember what the word sum means? Add. And what does difference mean? subtract. Okay, so we got to know those in order to set these up. So we want to define our variables. It's telling us the sum of two numbers is 98. The difference of those same two numbers is 42. What are the two numbers? Okay, so we've got to make two equations on this. And so that first sentence actually makes our first equation. So our variables that I'm going to use on this are just going to be x and y, right? So x is going to be my first number, and then y is going to be my second number, just so I know what I'm kind of dealing with here. All right, and then I can get this set up as a system. So this the first sentence there says the sum of two numbers is 98. So I don't know what those numbers are, so I'm going to say x plus y equals 98. And then that second equation is going to give me my second sentence is going to give me my second equation. So if I write this out, the difference of two numbers is 42. So now I've got x minus y equals 42. Okay, so looking at this, do you think substitution or elimination method might be easiest to do on this next one? You can do either. Yeah, because we don't even have to multiply anything by a number to get those to eliminate. All right, so let's do that. So I'm going to just put this here. So if I add these together, those y's eliminate, which is what I'm trying to have happen. And now let's just add the rest of the stuff together. So I've got 2x equals, what's 98 plus 42? Say that again? 140, yeah. Sorry, I heard 120. So you had it right. Okay, and then we divide both sides by 2. And so x equals 70. All right, so I have one of my numbers. Now, how am I going to use this x equals 70 to find my other number?
Replace it?
Yeah. Does it matter which equation I put it into? It doesn't matter on this one. So I would just do whichever one looks easiest to you, or, you know, sometimes people are just like, I'll just choose the top one. So it doesn't really matter on this. You could use either one. And if you don't believe me, try the other one and you'll see you'll come out with the same thing. All right, so on this, so that's the equation I'm choosing to use. And then I'm going to put 70 in place of my x here. So I'm going to have 70 plus y equals 98. So I just need to subtract 70 over, and then I get y equals 28. All right, so 70 is my first number, and 28 is my second number. So I want to emphasize that word problems need word answers. Okay, so whenever you're writing down your answers for any kind of word problems, make sure you're spelling out what those answers mean. If you leave just the number for the answer in these word problems, you are going to miss some points on the exam. And it's good to do it, because then on some of them it's kind of easier to see, does my answer make sense? On this one where we're just dealing with numbers, it might be kind of hard to tell. But on this next one that we go over, you'll kind of see what I mean by that. Okay? And so when I say state the solution in context, that's what I mean here. All right, 70 is the first number, 28 is the second number. Okay, so these next ones are called value problems. And notice how, like, So however this is set up here, I like to put things in a table just to be able to organize the information, make sure I know what's what. All right. And so usually, we're just putting the different items down the side, and then we're going to do the value and the total there. So let's look at this one because I already have one set up here. All right, 33,000 people attended a ball game at a stadium that offers two kinds of seats, general admission and reserved. The day's receipts were $222,000. All right, so that's how much they brought in that day. How many people paid $13 for reserved seats, and how many paid $4 for general admission? All right, so we got to decide, define our variables. Make sure that we do that to start off with. You can always use X and Y if you want to. Just keep it like that. But sometimes people look at it and go, okay, wait a minute. I'm trying to find out how many reserved seats I have and how many general admission seats I have. So maybe, sometimes people might use like R for reserved seats or G for general admission. So you could use those, or you can just use X and Y. Doesn't matter to me. Okay. So on this, I'm going to say X is going to be the reserved seats, and Y is going to represent the general admission. And sorry, I should be more specific on here. The number of reserved seats, all right, and the number of general admission seats. Okay, so now that I know what each of those are standing for, let's fill in what we know here. Okay, so let's look at this, just the number column here. Well, we don't know how many reserved seats we need, right? That's what we're trying to find. So I'll put X in place of that. And I don't know how many general admission seats there are, but I decided to call that Y. But it does give me the total number of seats or tickets that were sold. How many is that?
33,000.
Yeah, 33,000. All right, and then this first column right here makes our first equation. So I'm going to write that down here. So if I take X, the number of reserved seats, add it to the number of general admission seats, I'll end up with 33,000 seats. Okay. All right, now the value in this case is talking about the money. All right, so how much do the reserved seats cost? Well, it tells us right here, they're $13. And general admission, the value of those is $4. Okay, but there isn't a value, like a total value. That doesn't make any sense. So we don't need to put anything in that spot. Okay, but then let's look at this last one here. To find this last column, we're going to multiply these two columns together. So when I do that, I just get 13x, right? 13 times x, and then 4 times y. But then this total number, I've got to get from the story problem, the total sales. How much money was brought in? Well, total amount of money was $222,000. Okay, and now this is going to be my other equation. So I'll have 13x plus 4y equals 222,000. Don't know why that. Oops, let's see here. Let me erase that because that looks like it's. Oh, well, okay. It's all right. It just looks kind of weird. Okay, so we've got. So on this one, you could do substitution or you could do elimination. Both of them would probably be about the same difficulty and stuff. So I'm going to choose to do the elimination method on this one. But like I said, you could do either one. So I'm going to take this top equation and I'm going to choose to multiply it by -4. Why would I want to multiply that one by -4? How is that going to help me?
Eliminate y.
Yeah, do you see how that's going to help us eliminate that y if I multiply that through there? So that's the variable I'm looking to eliminate, is the y on here. All right, when I do that, let's put that down here. So -4x minus 4y. And then what's -4 times 33,000? Anybody have that on your calculator? It's going to be a negative number.
132,000.
Yeah. That looks good. -132,000. All right, so my y's eliminated. I made that happen, right? So then what am I left with here? I've got 13x minus 4x, which gives me 9x. And then 222,000 minus 132,000 is going to leave me with 90,000. I subtract those. All right, and then all that's left to do now is divide by 9. So x equals what? $10,000. All right, and 10,000 what? What does this x represent here? Well, we said that was the reserved seats. So 10,000 reserved seats. All right, now I need to find the general admission. So again, you can just use whichever one you want. I'm going to use the top one because that looks a lot easier to solve for y in. So let's put 10,000 in place of our x plus y equals 33,000. And then I just need to subtract that 10,000 over. And so I'm left with y equals 23,000. And these are the general admission seats. Okay. And so those are my answers here. Okay, so remember, word problems need word answers. Okay, so organizing your information in a table is really helpful. You don't have to put it in a table. I'm not going to force you to do something in a specific way. If you have another way that you want to do this and think it through, that is totally fine with me. This is just one way to help us stay organized. Okay, so we got 2 more types of problems that we're going to go over here, and then we'll be done. So this one is a percent solution one, and it's really going to be set up in a similar way that we just did the one above. All right, notice that down the side, I'm talking about the type of stuff that I'm mixing together, and then along the top are the different things, the amount, the concentration, and then the amount of copper altogether. So reading through this, Alexi and Nico use a metal alloy that is 23.5% copper to make jewelry. Now, an alloy just means it's like a mixture of metals put together. So sometimes they make an alloy to make like metal stronger, or sometimes they do it to make it softer, or just to give it different properties, or so it's not so expensive or something. So alloy just means a mixture with some metals. So 23.5% copper to make jewelry. How many ounces? All right, so this is what we're finding. How many ounces of an alloy that's 22% copper must be mixed with an alloy that is 24% copper to form 88 ounces of the desired alloy. All right, so we want to end up with this 23.5% copper alloy. Okay, and we're mixing the 22 and the 24% together to get that. All right, so we're talking about the ounces of it. All right, so again, we can just use X and Y if we want to, or if you like to use different ones, that's fine. I'm going to say A is the ounces, right, because we're trying to find the ounces. How many ounces of the 22% alloy? And then the Y is going to be the ounces of the 24% alloy. All right, so I've got my things defined here. That's going to make solving it a lot easier to make sure I know what's what. Okay, so I don't know how many ounces I need of that 22% alloy. That's what I'm looking for. So I called that X, and I called the 24% copper alloy Y. But then altogether, right, how many ounces do we want to end up with altogether? Right here it says 88 ounces, so that's going to be going there. All right, and then remember this first column is going to make my first equation, so X plus Y equals 88. All right, then this next column right here, when we're dealing with percentages, we've got to change those to decimals before we can put them in our equation. So this concentration is 22%, but how do I change that to a decimal? What would that be as a decimal? Yeah, 0.22. All right, and then 24%. Similarly is going to be 0.24. The 23.5% is going to be 0.235. Remember, I'm just when I'm changing from a percent to a decimal, I'm just moving that decimal point 2 places back. All right, on all of those. Okay, and then just like we did above, I just need to multiply these two columns together to get that last column. So X times 0.22 is going to be 0.22X. And when I multiply those together, I get 0.24Y. And now this next one here is where a lot of times people make a mistake. All right, just like we were multiplying these together, we still got to multiply these together. So in your calculator, figure out what's 88 times 0.235. Ready to come up with that? That's 20 point something, I think. What is that? 20.68. Thank you. All right, and then this column is my second equation. So 0.22x plus 0.24y equals 20.68. All right, and then you can solve this here. So on the last one, I did using the elimination method. So let me show you how you can do this with the substitution method. Because either way works, it's just up to you on what you want to do. If I take this x plus y equals 88, and I solve it for x, right, because if I'm using the substitution method, I want one variable by itself, so I'm going to choose to subtract that y over. So x equals 88 minus y. And now I can take that 88 minus y, and I'm going to put it in place of x in my bottom equation. Okay, so when I do that, go ahead and write this in here, 0.22 in place of that x. So I got to put parentheses, 88 minus y, and then plus 0.24y equals 20.68. All right, now let's distribute that through so I can get rid of those parentheses. 0.22 times 88 is going to give me 19.36. Distributing it here, I get minus 0.22y plus 0.24y equals 20.68. Sorry, those points look a little bit weird. Kind of keeps doing some weird stuff here. All right, but let's combine those like terms together on this. That's going to give me positive, right? And that's going to give me 0.02y. So I've got 19.36 plus 0.02y, when I combine those together, equals 20.68. Let's subtract that 19.36 over. So I get 0.02y equals, let's see, when I subtract those, what do I get here? 1.32. And then I need to divide both sides by 0.02. All right, remember when I'm dividing by a really small number, it makes my answer a lot bigger. Right? And so when I do that, I get 66. Okay, but 66 what? What did I find? What is that 66? Let's go back up here to when I defined my variables.
Ounces, 24% copper alloy.
Okay, so the 24%, because we found the Y, right, and we called that the 24% copper alloy. So we need 66 ounces of the 24% alloy. All right, and then to find what our X is, we can actually go back to this equation over here where X is already by itself. That might make it a little bit easier to do. All right, so I have X equals 88, and then in place of that Y, I'm going to put 66, so minus 66. And so X equals 22. So 22 what? Ounces of the 22% alloy. Okay, so those would be my lovely answers there. Okay, so a lot of these just take some practice. So, make sure that as you're working through these problems, if you get an answer right, but you're like, gosh, that was kind of a fluke that I got it right, I really don't know how to do it, make sure you, do a similar problem until you really got this down. Okay, we've got a test coming up here soon, so I don't want you guys to, just kind of brush over things, because I want to make sure you're going to do good on the exam. So you're going to be taking the exam next week. All right, I think I have it in there Wednesday, Thursday, and Friday in the testing center. If you're not signed up yet, then please get signed up, okay, to get that reserve place to take that test, a date and a time. Okay, we're going to do one more problem here, and then we will end. So it'll be a few minutes over 7, but we're pretty close. All right, on this one, we've got an airplane travels at 800 miles in 4 hours with the wind. The return trip against the wind takes 5 hours. What is the wind speed and the speed of the airplane in still air? So think about what's going on here. There's an airplane, and if it's going with the wind, that means the wind is behind the plane and it's pushing it faster than what the engines are really making it go. All right. However, if the plane's going against the wind, meaning the wind is coming straight at the plane, right, going into it, then it's slowing the plane down. So that's important to keep in mind here. Okay, when I set this up, my two different equations are going to be with the wind and against the wind. Those are the two different equations I'm going to come up with. And notice how it has here that we're using distance equals rate times time. So that's a formula you should have memorized. And we know that we're going to be using that formula because we can see in here we got things with distance, rates, and times. Okay, now be careful with this rate part. This is the part where a lot of times people make a mistake. Notice how it says here, what's the speed of the wind and the speed of the airplane? Right? So a rate, in this case, is going to be the plane speed plus or minus the wind speed, depending on if it's going with the wind or if it's going against the wind. Okay, so I'm going to define my variables as my plane speed is going to be P, and I'm going to call W my wind speed. Okay, but you can use whatever variables you like, but that's what I'm choosing to use on this. Okay, and then keeping in mind that my rate is plane speed plus or minus the wind speed. And I can't mix those up. I can't put wind speed plus or minus the plane speed. The plane speed has to go first because the plane speed has to be higher, a higher number than the wind speed in order for the plane to stay in the air. We can't have a higher wind speed than the plane speed. Okay, so let's think what we know here. So we're going to fill in this column with distance. Well, it tells us we're going to travel 800 miles. And this is a round trip, so I'm going 800 miles with the wind, and then on the return trip, 800 miles against the wind. Okay? And then I can see that, so 4 hours with the wind, so this top one is with the wind, so time is 4 hours, and then 5 hours against the wind. So that goes here. Okay, so now this next part is where a lot of times it gets, a little tricky. So remember, we're going to use this whole idea of this rate, right? Plane speed plus wind speed, because that's what I'm trying to find. You see, I don't have any variables in here yet, and I've got to put both of those variables in here somewhere. So if I'm going with the wind, that's pushing the plane faster, so that's going to be the plus part. So I'm going to have my plane speed plus my wind speed. Where if I'm going against the wind, that's slowing me down, so I'm having the wind speed, and I'll have to subtract off the plane speed, and I'll have to subtract off what the wind speed is from that. Okay, and now I'm going to set this up, distance equals rate times time. That's my two equations here. So let me do that down here. So 800 equals, and these are being multiplied together, but I'm going to write it like this, 4 parentheses P plus W. All right, because this needs to be in parentheses here, but we don't usually put that 4 and 5 after it. And then the other one, 800 equals 5 times P minus W. Okay, at this point you could distribute the 4 through and distribute the 5 through and then try and solve it from there. But let me show you another way that you could do this that would be even faster. So we see that 4 is connected to all of that by multiplication, so I can undo multiplying by 4 if I divide both sides by 4. All right, so those 4's divide out, and I'm left with 200 equals P plus W. And then similarly over here, let's divide both by 5. All right, so 800 divided by 5 is going to give me 160. All right, and I'm going to put this, I'm going to write it over here. So 160 equals P minus W. All right, now I'm going to use elimination on this because I can see eliminating those W's there is going to be really easy for me. All right, so those W's eliminate, and then I just need to add the other things together. So 360 equals 2P, right? P plus P is 2P, and then let's divide by 2. So P equals 180. But 180 what? All right, P is the plane speed. What am I dealing with up here? Well, I've got miles, all right, and I've got hours. So this is, yeah, so 180 miles per hour. So on some of the story problems, it might be kilometers per hour or something like that. So make sure you have that unit on there. And this is the plane speed. All right, and now we need to find the wind speed. And again, I can just kind of go back to, one of my two equations there. I could go to one of these two. All right, so maybe I'll just use that top one. Let's see, I'm going to do it in a different color just to make sure. So I'm going to use that top one. So 200 equals P plus W. So I'm going to put 180 in place of my P. And then I just need to subtract that 180 over. So I get 20 equals W. So 20 what? Miles per hour again, and that is going to be the wind speed. All right, and so if I'm thinking about this, do those answers look like good answers? Well, sure. And I didn't end up with any negative speeds. If I ended up with like negative miles per hour, you should be re-looking at what you did there. And my plane speed is less than my tongue-tied today. My wind speed is less than my plane speed, so that is a good thing. If that wind speed was greater, then yeah, you'd want to look at your work again and see where you maybe made a mistake. Okay? All right, I hope that was helpful for you on those two. So we'll, on Monday, I'll hold another one of these sessions and we'll go through 2.2 and 2.3. All right. If you have some questions, definitely stick around and I'm more than happy to help you with those. Okay.